Problem number 12. A 50 grams piece of clay is thrown horizontally with a velocity of 20 meters per second, striking the bob of a stationary pendulum with length L equals 1 meter and a bob mass of 200 grams. Upon impact, the clay sticks to the pendulum weight and the pendulum starts to swing. What is the maximum change in angle of the pendulum? The following information applies to problems 13 and 14. Angela the puppy loves chasing tennis balls, so her owners built a tennis ball launcher. It fires balls along the floor at some initial speed, applying no rotation to them. The balls initially slip along the floor, then start rolling without slipping. Ignore the potential deformation of the ball and floor during this process, as well as air resistance. Problem 13. Which of the following plot pairs could show the linear speed v and rotational speed omega of one of the balls, over time? Assume the floor has a constant roughness. Problem 14. There are three kinds of balls that can be launched in this setup, all having the same radius r. First, a regular tennis ball, a thin spherical shell of rubber, of mass m1. Second, a solid wooden ball of mass m2. Third, a solid rubber ball of mass m3, where m1 less than m2 less than m3. All three types of ball emerge from the launcher with the same velocity. For which ball will the final velocity be highest? Problem number 15. A uniform rigid rod of mass m and length 2L is attached to a massless rod of length L, which is fixed at one end to the ceiling and free to rotate in a vertical plane. The massive rod is connected to the free end of the massless rod. Suppose an impulse J is applied horizontally to the bottom of the massive rod. Determine the relationship between the magnitudes of the angular velocity omega small of the massless rod and omega capital of the massive rod immediately after the impulse is applied. The moment of inertia of a uniform rod of length d and mass m about its center of mass is given by I equal 1 over 12 md square.